Assalamu alaikum, dear students. This is your third lecture. In the previous lecture, we studied about some basic definitions and the definition of element. In today's lecture, you are going to study about samples of element, compounds, mixtures, and the types of mixtures. You might remember we studied elements. An element is a pure substance which cannot be split up into any other simpler substance by any ordinary physical or chemical processes. Samples of element. In 1814, Berzelius suggested the system for representing elements with samples. What is sample? An element symbol is a one or two letter abbreviation for a chemical element, and it is the shortest name of an element. One thing you might remember, it is the same chemical symbols are used all over the world, no matter which language is spoken, which makes them very useful. Okay. In most cases, the first letter of the name of an element is taken in capital letter as sample. But in some cases where the first letter has already been used, then the initial letters in capital together with a small any other letter from its name are used. For example, carbon, boron, and hydrogen. Now in these three you can see that the first letter of the name of an element is used, while in case of magnesium, in case of aluminium and calcium, it is clear that a two-letter symbol is used. Look at the first one where carbon and calcium, both of these start with C. So if we do represent both of them with capital C, it will create a problem. It will not clear our point whether we are talking about carbon or whether we are talking about calcium. In order to avoid such ambiguities, this one letter for carbon C is used, while for calcium C along with A is used. Okay. Now, there are certain elements that their samples start with their Latin or Greek language name. For example, antimony, whose name in Greek letter it is whose Greek name is terbium. So the sample SB is taken from this name. Similarly, copper, cuprum, Cu, gold, aurium, Au, iron, ferrum, Fe, lead, plumbum, Pb, mercury, hydrogarium, Hg, potassium, kalium, K, silver, argentum represented with Ag, sodium, natrium, and its symbol is Na. Okay, our next topic is compound. If you remember, while classifying substances, we classified them into pure substances and impure substances. And in pure substances, we said that elements and compounds are pure substances. A compound. Chemical compound is a chemical substance consisting of two or more different chemically bonded chemically elements with a fixed ratio determining the composition. One another thing, the component element must undergo chemical changes during compound formation. And these compounds may be characterized according to the type of chemical bonds holding the atom together. For example, the molecules, they are held together by covalent bonds, while ionic compounds are held together by ionic bonds. Intermetallic compounds are held together by metallic bonds, and complexes are often held together by coordinate covalent bonds. And next very important thing, it is that the properties of compound are different from the elements from which it is formed. For example, water. Now this water, you can see it is made of two elements, hydrogen and oxygen. And the ratio of hydrogen and oxygen in water is 2:1. As I said earlier, that the properties of the elements are different from those when they are result in the formation of compound. It is, for example, if you talk about element hydrogen, this element hydrogen burns while oxygen helps in burning. In absence of oxygen, nothing would burn. So when they combine together and result in the formation of water, you can see, and it might be your observation, that water neither burns nor burn itself. It also do not help in burning. So this is what we talked here. Okay, now coming towards that, if you change the given ratio of a compound, then a different compound is going to result. As we said that the ratio of oxygen to hydrogen in water is 2:1. Let's suppose an oxygen atom is added to this, which will result in the change in the ratio, and we will get 2:2. You should keep in mind that this 2:2 will result in a different compound, and that is hydrogen peroxide. This hydrogen peroxide, it is a mild antiseptic. It is used on the skin to prevent infection of minor cuts, burns, and this hydrogen peroxide, it is also present in clothes and hair bleach. Okay, next is formula of compound. Compound, they are always represented by chemical formula, and the formula of a compound is going to give you information about the symbols of the element and their combining ratio. Examples: marsh gas, whose chemical name is methane, and this is chemical formula. It can be clearly seen that it is made up of carbon and hydrogen, and the ratio is 1:4. Similarly, table salt, chemical name is sodium chloride and made up of sodium and chlorine atoms. Caustic soda, whose chemical name is sodium hydroxide, and it is made up of sodium, oxygen and hydrogen. Next is mixtures. But before going into mixture, you might get it clear that compound versus molecule. You know, sometimes a compound is also called a molecule. Like they can be used interchangeably, and they are sometimes referred to as one as the same thing. But some scientists make a distinction between the types of bond. For example, if it is a covalent bond, you will refer it as molecule. And if it is an ionic bond, it is known as compound. Okay, now coming towards mixture. As discussed earlier, that mixture are impure substances. And mixtures, they are the product of a mechanical blending or mixing of chemical substances, and those substances can be elements, they can be compounds, they can be both, right? Okay, to be a mixture, the substance cannot form or break chemical bonds with each other. Here are different examples. Here you can see that this is a mixture of atoms. This is mixture of atom and molecules. This is mixture of molecules, and these molecules are made up of element. While this is mixture of elemental and compound molecules. This is a molecule of element, while this is molecule of a compound. In order to be considered a mixture, the substances must satisfy three general properties. Number one, the component in a mixture can easily be separated by any physical method like filtration, sublimation, condensation, etc. They each keep their own chemical properties, and the proportion of the compound is variable. Examples: sugar dissolved in water, alloys, which is mixture of metals. You can also take seawater as an example, which is a mixture of various salts and water, air, which is a mixture of various gases like carbon dioxide, oxygen, nitrogen, argon, neon, etc. Ink, it is a mixture of colored dyes, and these dyes can be easily separated through chromatography. Now coming towards the types of mixture, there are two types of mixture: homogeneous mixture and heterogeneous mixture. Homogeneous mixture, they possesses the same properties and combination throughout the mass. Example: alloys, salt in water, alcohol in water. Heterogeneous mixture, they possesses different properties and compositions in various parts. That is, the properties are not uniform throughout the mixture. For example, salad, air, oil and water, sand and water. Thank you.